My name is Eben Haber, Senior Software Engineer at Couchbase, and along with my colleague Isha Kandaswamy, also a Senior Software Engineer at Couchbase, we're going to be presenting some important UI changes in the most recent release of Couchbase. Specifically, we'll start by discussing UI support for collections, a brand new feature in Couchbase 7.0. Next, a discussion of how to use the new transactions feature. And finally, we'll be showing off the charting feature, which gives you a new way to see your data. So before Couchbase 7.0, we supported up to 10 buckets for data. Specifying a bucket was simple. There weren't that many of them. Now, buckets can contain potentially hundreds of scopes and collections. This is great for organizing your data, but require changes to the UI in a number of places. I'm going to go over the most important collections changes with regard to query and analytics. Now, I'm going to be doing this as a demo, so I will switch over to this simplest place where we have scopes and collections showing up is the documents page. The old documents page just had a bucket selection menu. Now we can also select among any available scopes and collections. And it works the same way as it always did. You select a new collection, you can see new data. Similarly, the import panel needs a menu for buckets, scopes, and collections in order to allow you to specify where you want the data that you're importing to end up. So simple so far. It gets a little bit more interesting with the query panel. Starting on the right-hand side, just as before, the schema panel will show you a list of all your available buckets. In the old days, these were just buckets and it would show you the schema of the data in the bucket. Now, since we might have a whole bunch of scopes and collections here, these are closed by default, but if the user is interested in a particular bucket, they can click on the triangle to open it up. If they want to look at one of the scopes, they can click on the triangle again. And if they're interested in the schema of a collection, they can click on that and see what fields can be found in that collection and what indexes are available. So it should be noted that the UI is only inferring schemas for those collections that you've opened up. So if you want field names to be available for autocomplete when you're querying, then you want to make sure that these are opened up. Now, thankfully, the UI remembers which collections you've opened up. So if I come back tomorrow and reload my browser, it will open up the same collections as before. Now, queries can be a lot more verbose with scopes and collections. So instead of just saying select star from airline, I now have to say select star from travel sample.inventory.airline. And if I'm using different collections, then there's a lot of extra verbiage going on. This works, but maybe it's more typing than you want to have to do. So one way around that is with the query context menu, which lets you specify a default bucket and scope for interpreting queries. So here's a shorter version of that query without the bucket and scope in the query. And I just want to say, OK, this airline is to be found in travel sample inventory. And I can run it and get the same result. But it is important to make sure to reset the query context if you want to start querying other buckets and scopes. So if you just set it back, now it doesn't have a query context anymore. So you have to go back to specifying the bucket and scope. Now, so that's query. Analytics is the same way. Before, analytics would let you specify a bucket and optionally a where clause to import data into analytics. Now, of course, we have to have buckets, scopes, and collections if we want to import something. But much more interesting, we have a new mapping option, which lets you map multiple collections. Let's say I want airline, airports, and routes. And I want to import all of these into analytics at the same time. So here it is. It's ingesting the data. And OK, yep, there. At least it's got the airline data in there. And I can run a query on it. Now, it's worth noting that the Hierarchy is flatter in analytics. There's only 2 levels instead of the bucket, scope, and collection. So it kind of fakes it by having a container referred to as bucket or travel sample.inventory in this case. So the query context is just one menu instead of 2, since you're only selecting that top level container and then your collection. Now, those are the most important collections features with regard to querying. The other really cool feature in the most recent release in 7.0 is transactions. The idea of transactions is that it gives the user the ability to run one or more queries at once, such that they either all succeed or none of them succeed. Now, most of the time, you're going to be running transactions via SDKs, but if you want to run a transaction for testing purposes, or just you have a one-off situation where you want transactional behavior, you can do it. It is supported from the UI. So there are 2 ways to run transactional queries in the UI. The first is a multi-statement transaction, and this is the traditional way it's always taught in school. Always it's described usually in textbooks in terms of bank accounts. So I created a very simple collection. I've got 2 bank accounts, one for me, one for Isha. We've got a balance and an ID. Now, let's say I want to do something like transfer $20 to Isha. That means I've got to do 2 update statements. I've got to update my account. I've got to update Isha's account. And I want to make sure that either both of those statements go through or neither of them. Now, just as with traditional relational databases, you start with the begin statement. So I might say begin work, semicolon. Now, if I hit enter right now, the UI usually, if you hit enter after a semicolon, runs the query, but I don't want to run the query, so I'm going to use shift enter. I could also use control enter, and it will ignore it won't run the query yet. And then I want to say update accounts, set balance equals balance minus 20, where ID equals Eben, because we're taking $20 out of my account. And then I hit shift enter again, so I don't run the query yet. And I say update accounts, set balance equals balance plus 20, where ID equals Isha. And then finally, I want to say commit the work. And now I can just hit enter and it will go through. Or I could have clicked the execute. And so what I see is it ran the query, it got a transaction ID, it ran the remaining queries, and then finally success. And if we go back, we can see indeed it took $20 out of here and put $20 in there. So now if one of those queries had run into an error, if it had failed for some unknown reason, then all the work would have been rolled back. So that's the beauty of transactions. It's more expensive than a regular query, but it can let you do things that you couldn't do otherwise. So that is the traditional multi-statement way to do transactions. But there's another way called an implicit transaction. This is where you have a single statement, usually an update, and you want to make sure that the whole thing runs to completion. So if I'm a bank and I want to give everybody their interest for the month in their bank accounts, I could say, update accounts, set balance equals balance times 1.001, because interest rates are terrible. Now, just as before, I could have wrapped this in a begin work, end work, and it would behave the way we'd like it to, which is that it will update everything or update nothing. But I can also save a little bit of typing and use this run as transaction button. And this runs it as an implicit transaction, meaning it will treat that statement as if it were in begin work, end work, commit work. And yes, it says, are you sure you're updating everything? And it worked. And I guess if we go back here, we can see, yes, we got a little bit of interest in our account. Not very much, though. OK, so that concludes my discussion of the collections and transactions support in the UI. And now Isha and I are going to talk about the new built-in charting feature in 7.0.2. Next slide, please. So charting is something that is a really valuable way to look at data. And there have been requests for a long time for us to add it to our way of looking at the results of queries. But the problem is that we're dealing with flexible schema JSON data with nested documents and arrays. So if we want to be able to chart it, all the charting libraries expect regular tabular data. And so the way we do that is we need to flatten the hierarchies. So we need to take the JSON document, and if we've got subdocuments, we need to flatten those. So a subdocument with, say, in this example, we have subdocument B with sub attributes C and D. Those become top-level fields B.C and B.D. Now, unfortunately, there's really no good way to automatically handle arrays because there are a number of different ways they could be interpreted. But you can do a manual approach by just simply writing a different query. Take a look at the unnest feature of Nickel as a way of taking array values and linking them to the top-level values. So now I'm going to hand things over to Isha, who did the biggest amount of work in making this charting happen.
Thanks, Eben. So let's take a look at all the different charts that we support. And so we support 8 different kinds of charts as of 7.02. We have the scatter chart, the connected scatter chart, the line chart, the area chart, the bar chart, the grouped bar chart, the pie chart, and the donut chart. Now, I'd like to go over each different chart as I'm giving the demo. So let's just switch over to the demo. Okay, so here we can see that we're in the Query Workbench tab. Let me quickly remind you guys, like Eben showed, we have 3 separate buckets. One that contains COVID data with 2 scopes, one for county and one for state, and then 3 collections each, where one has information about vaccination records, one is demographic information, and the other one is cases and deaths per day. We also have a bucket that depicts rainfall data, and that rainfall data, we'll look at the rainfall that Cupertino received over the last 10 years, I think. And then we have the travel sample data, which gives you information about the various airports across the world. So let's actually start with the airport data. And I have, like you can see, we have this really nice query history, and I have a bunch of queries that I'm going to close and run. So let's quickly look in a tabular format because it's a little easier to understand. We have the airport name, the city, the country, and geolocations. And time zone. And we want to chart this data in the XY or scatter chart form. And what is a scatter chart? A scatter chart is actually just a bunch of dots that represent individual data points, right? You're plotting XY values to show the relation between whatever values you're plotting. And here we're plotting longitude versus latitude for specific airports in the United States. So you have this really nice map of the United States airports with different dots representing different information. But we haven't gathered this yet, right? So I said we could actually do like a scatter gather chart where we gather data or group data based on a certain type. So let's group it based on time zones. And we see this really nice distribution of the United States time zones, including Alaska and Hawaii. And you have this really pretty picture where you can see there's a random n data point. So you can actually find discrepancies in your data using charts. So let's look at something else. Let's look at the rainfall data, and let's plot those as an XY chart. And let's look at, right. So this is the rainfall data for multiple years. Like you can see above here, it's for 2010, 2014, 2016, 18, and 20. Now, I don't actually know what data belongs to what year, so I'm going to gather based on the year. And now I have this really nice representation of rainfall data at Cupertino over the last 5-10 years. But I see that I'm missing 2012, so I'm going to add in 2012 and re-execute this query, and voila, I have the new data point. So I can actually interpret this by saying, hey, 2014, we had really low rainfall, but then eventually it went back up. And then you can see the effects of climate change because the rainfall, like we're going more and more into drought. So yeah, so what is a scatter gather chart? Essentially, it just represents relationships between multiple data points, which is your X and Y axis. Let's next look at a line chart, and let's look at some fun stock data. So here I wanted to look at Couchbase stocks, and I'm using this API from Polygon.io to get my stock data. And I wanted to look at the data from the beginning of time until the end of September. Let me just quickly show you how the data looks, right? So here we're using a nest, something that Eben discussed beforehand. So we get all of these really nice values from the JSON API, which is external to Couchbase, right? It's not within a bucket here. We use the inbuilt curl scalar function to ping an external REST API JSON endpoint, retrieve that data, unnest those results, and then actually do some fun stuff on those results. Here we're converting the time, which is in milliseconds, to date format, ISO 8601 date format that we find is compatible with charts. And then we're going to plot this as a line chart over the date. And we see, let's plot the high value, and we see that stock price has moved quite a bit. Now, with line charts, we're basically looking at the progression of one value over another value, which is usually an interval of time. Here, I want to look at individualized data points. I'm going to look at something called connected points chart, which is basically an XY chart and a line chart merged together, so I can see the individual data points. And this should give me exactly what those data represents. And let's also look at some crypto data. So I have some crypto data similarly from Polygon.io, and I'm going to execute this query. But this time I want to look at it as an area chart, which is basically a distribution of data. And this combines the line chart and the bar chart to show you how any given value changes over a particular interval, right? So we can see this is just for the month of September, and we see how the value of Bitcoin has changed over this month. I mean, it's gone down quite a bit. Okay, so now let's actually quickly go over to the bar chart. And I want to show you, it's very similar to the area chart, like I said, because the area chart is literally a line chart and a bar chart in one. But a bar chart represents categorical data with the rectangular bars heights being proportional to the value that we're representing with the chart itself. But here I want to compare what the closing cost was for the high point and the low point every day was for my Bitcoin data. So I'm going to switch to a grouped bar, and essentially I'm going to plot all three. Now let's resize the data and see. Here we can actually do a nice comparison of the low point, the high, and the closing cost for the data itself. Let's also quickly look at the COVID data that I have, because I wanted to see some information about what's happening with at least one dose, So let's quickly look at the tabular data first, right? So this is basically telling me that this is giving me the fully vaccinated count, how many people actually had one dose, how many people are partially vaccinated, what their demographic information is, whether they're 12 years and up, what their race is, what their ethnicity and race is. And that's pretty nice to see. So let's also quickly take a look at another grouped bar chart example where we'll compare the information for J&J doses, the Johnson & Johnson, Moderna, and Pfizer vaccines. So here we can see that people actually seem to getting more Pfizer doses than J&J doses. And this is just for 2021 September. So that's a pretty cool thing to look at from our COVID data. Okay, now that we've looked at the bar, the group bar, let's actually look at the pie chart, which is basically parts of a whole. And let's look at the COVID demographics for that year. Let's look at a total population of California based on race and see, here we go. So we actually see this is how the demographic looks in California. Anything below 3% of the total value is put under others. And here others is really small compared to the entire set of data. So it's separated out here in the corner. So this gives me what the population total is. But now I want to know how many of these have been vaccinated, how many of each type of race has been vaccinated. So I'm going to run a group by based on race and sum all the vaccination records. And then I get to see how many are vaccinated. Now, if I just go back and forth, I should be able to do a nice comparison of the two charts to see, hey, so it looks like within the Latino population, not everybody is, getting their vaccines. So maybe we can do something to help. So these kind of charting capabilities help in the public health sense quite a bit. Now say I wanted, I also have a donut chart. So if you prefer to see it as a donut as opposed to a full pie chart, it's the same thing, but it just looks nicer. We also have a download button. So we could download the chart in the form of an SVG and then open it up and store it and share it with whoever we want to share it with. So we have that capability. So yeah, so those are the charting capabilities that we have. Let's quickly go back to the presentation. I'm going to present again. So we looked at all the different types of charts that we support. And we also have some additional points or notes about these charts that we support. So with the x-axis, we only support numeric values or date time timestamp values. And with these date time timestamps, we enforce it to be ISO 8601 formats. And even within those formats, we only support 5 specific format strings. Also the y-axis, especially for the XY charts, must always be numeric. We don't support ordinals in the y-axis. For any one of the pie, donut, bar, grouped bar charts, essentially the values that are used to group data, they have to be numeric. But for the labels themselves, they can take on any value. They could be numeric, dates, times, timestamps, strings, any one of them. With geodata, we don't explicitly have a map, but we can plot them like I showed you in the beginning with an XY chart. And we also have the ability to hover over each individual data point, so you should be able to see what that data point represents. And obviously you can download the chart as an SVG. We also can resize the chart window and it'll re-render the chart to fit in the canvas, like we saw in one of the examples. We have some upcoming features in the future releases. Basically, we'll add different types of additional charts, such as maybe multiple area charts or histograms or bubble plots or heat maps. We also plan to support strings on the X and Y axis. Like I said before, we only support numeric data types and date time timestamps now. And we also plan to support more date time timestamp formats and maybe some other fun UI features. But yeah, that's what we have right now. And hopefully it'll help people understand their data in a more convenient manner because they don't have to switch between using the Query Workbench and a third-party Tableau or Excel or any third-party tool. So we have a couple of upcoming features, we have multiple charts that we're going to implement, stack charts, percentage bar plots, heat maps, density maps, multi-area charts. We're also going to add support for strings on the X and Y charts. And then we're going to support more date time timestamp formats, and hopefully some more fun UI features. So thank you so much. That's what we have for you today. If you guys have any more questions, please feel free to reach out to us at the email addresses on the slide. And also, if you have questions, you can comment down below and then we'll try to answer them. Thank you so much for joining us at Connect. Cheers.